about continuous random variables. And the other day when I gave you notes, I talked a little bit about kind of taking you back to Math 1 and talking about what discrete variables or discrete values are, right? They were individual points on a graph. What are continuous? What happens when you have a continuous graph? Exactly. Yeah, there's medium. You can connect the points, right? Yeah, you have values between. Where discrete, it was a certain set of values and there was nothing in between them that you could use. In this one, continuous random variables can take any value in an interval on a number line. Can take any value in an interval on a number line. Now in stats we don't really deal with infinity much, so the interval part it's usually limited in some way. So there are no gaps. All the fractions in between values are fair game. That's it for notes. Told you it was short. You ready for an example? Okay. This is on page 373. You don't have to look if you don't want to. I think I'll give you enough information. It's about young women's heights. And the problem says that women's heights follow a normal. Why did I write a B for an M? I don't know. It's probably the ringing in my ears from last night. Follows a normal pattern, and our average is 64 inches, and our standard deviation is 2.7 inches. So these are population values, right? And the question is, what's the probability that at random we choose a woman from the population that's between 68 inches and 70 inches? Now, does anybody recognize where we have to go from this? That's right. We standardize. When in doubt, standardize. So the stuff that we're going to be doing today, we've really already done. We've just never really quite looked at it so much as a probability thing. But the reality is table A is a probability table. It is entirely a probability thing. So when I first talked to you about this class on day one, and I think I might have made a statement something along the lines of welcome to word problem hell, what I probably should have said is welcome to probability. That would have been a little friendlier, right? Okay? So, yeah, when in doubt, standardize, and that's exactly what we're going to do. So, remember, x minus mu over sigma. In this case, in terms of context, this is going to be a woman's height minus the mean of women's heights, all divided by the standard deviation of women's heights. I want to draw this out a little bit. I highly recommend drawing the curve, filling in your information. I think for me, I know for me personally, if I can draw the situation, I can almost always answer it. If I can't make a picture, then it means that I probably don't understand it as much as I maybe should. So I've got a normalish situation. Here at the middle, at the mean, that's going to be 64 inches. And it's looking for the probability that we get somebody that's 68 to 70 inches. Now, I'm going to estimate with my drawing, but I know that 68 inches is more than one standard deviation away from the norm, because one standard deviation would be 66.7 inches. Does that make sense? So I'm going to go a little bit past where I think one standard deviation is, maybe right here. Say this is 68 inches. And 70 inches is, well, just more. I don't know exactly where more, but I'm going to put that there. And I'm looking for the probability that we draw somebody out of this part of the curve. So I need to standardize and get the z-scores for this. Remember, this z-score here would be 0. So this is going to be 68 minus 64, right? The lower height minus the mean over the standard deviation. And I have an answer of 1.48 for that. And this is the z-score. So this would be 1.48 standard deviations away from the norm. And then if I do the same thing with the 70 inches, I get 2.22. So the next step, if you don't have one of these, I'll give you one here in a minute, but the next step you'd go to your table A. So I'm going to look at, actually I'm going to look at, well, I'll get them both written down. 1.48 is going to be 0.9306. I'll write that probability there, just kind of to help. It's a note for me. And then 2.22, if I go to that one, that's 0.9868. So remember what these values mean. almost 99% of the women are less than 70 inches, and 93% of the women are less than 68 inches. So the numbers in between that are going to be 9868 minus 9306 for about 5%. 0.0562, and this would be my percent. Now if I was answering this for an AP question or for a test question or something like that, I would say that 0.0562, or maybe change it to percent, 5.62% of the women in this population would be between 68 and 70 inches. I suppose you could say something like there's a 0.0562 probability that a woman chosen at random from this population would be between 68 and 70 inches. That'd be another way to answer this. I think that would be acceptable. Maybe that would even be better, talking about the probability, because they are talking about what's the probability of pulling a woman out of this population. Okay. Cool. So a bit of a break from the new stuff. We just get to practice some of the old stuff, but think about it a little bit, perhaps maybe a little differently than we did.